Here we are discussing about a project, design and analysis of energy efficient approximate multiplier for image processing and deep neural network. Here the approximate computing is an effective method to improve the efficiency in applications where exact precision is not critical, such as the image processing and deep neural network. This work focused on the design of 8-bit approximate multiplier using a 3 technique, that is a recursive, bitwise and hybrid approach. Here the recursive method uses a small submultipliers to preserve accuracy, making it suitable for moderately error sensitive tasks. Okay, and the second one is a bitwise approach, employs a OR based simplifications which significantly reduced hardware complexity, and it's ideal for highly error tolerant applications. And third one is a hybrid technique. This technique integrates approximate compressors with a partial product optimizations, offering a balanced trade-off between computational accuracy and hardware efficiency. Okay, so here this multipliers are designed for the task like image smoothing, edge detections and sharpenings, where small errors do not drastically affect output quality. They are used in a DNN, especially for the large scale matrix multiplications, is also explored due to the inherent tolerance of neural network to minor computations errors. This implementation is carried out using a Verilog HDLs and synthesized on Xilinx Vertex 5 FPGA platforms and designed or evaluated based on a key performance metrics such as power consumptions, area utilizations, delay and error rates, and compared with the traditional multipliers to assign the gains and the efficiency. Now we can verify the paper. So this paper is fully designed for the approximate multiplier model, okay, for image processing and deep neural network. Okay, so here they have designed 3 different multipliers. We already discussed in abstract. Okay, so this 3 different multipliers, it's a separately efficient one. Okay, so first of all, this multipliers we need to compare with the traditional method. So traditional method means it's normally come with the 8x8 exact method. It's using a normal half adders and full adder based architectures. Okay, so these architectures, it will take more logic sizes. For that reasons we have designed this 3 proposed technique, a recursive, bitwise and a hybrid method. Okay, so here the first work, figure 1. Okay, so the structure of exact 8x8 and then multiplier. So this is a partial product generations and this is architectures. Okay, so here what they are doing means they are not doing a normal traditional exact method. Okay, so traditional exact method means it will become with a number of half adders and full adders. So here for the novelty, they are already splitting the work in the different number of adders. Okay, so that is adder 1, adder 2, adder 3, adder 4, adder 5, adder 6. Okay, so using this different number of adders, so this work designed with novelty architectures in the exact method. Okay, here it will be take more logic sizes or less logic sizes, means it's a normal one. So if you are splitted the architectures only, not we are reduced any architectures here. Okay, so as per this method, here the exact forms, we have splitted only 3 different adders, adder 1, okay, this is adder 2, okay, and adder 3. Okay, so we close this work in adder 3 method only, not adder 6. Up to adder 6 we are not used. Okay, so only adder 1, adder 2, adder 3 we have used, and we have closed this exact multipliers. Okay, after that we use this same method in a recursive method and bitwise approach. So first of all, we need to analyze the recursive method. Recursive method, it will be splitted the 8x8 multiplier for LSB and MSB. That means 8x4 multiplications. Okay, so here the B0s, right, the partial product, it will be generated for A0 to B7 and B0 to B7. So here the A0 to A7, they are used for common one, and B0 to B7. So here the LSB part means B0 to B3 and B4 to B7 is a MSB. Okay, so this is a LSB partial product and this is a MSB partial product. As per that, they are splitted. After that, the splitted partial product, it will be reduced using the number of adder tree architectures. So that is a this colors variations. Okay, so here this is a adder 1, adder 2 and adder 3. Okay, the same method it will be handled on the multiplications, must be multiplications. After that we reduce the final output, okay, and we taken as a final partial product output. Okay, so this is a recursive method. And hybrid method means this is a one. Okay, so for hybrid method they are introduced something, the new optimizations method. Okay, so here it will be covered up with the PBO10 and PBO3, PBO5 and PBO7. Okay, so this method they have introduced. Okay, so this methods mostly integrated with the OR based architectures. So here they are used only the OR gate, okay, and reduce the partial product. Okay, so this will take very less logic sizes compared to the exact method and recursive method, but it will come with the approximations. Okay, so this is approximations, but this OR gate functionality they are given only in the LSB, so it will be come with the LSB approximations. Okay, so it's not disturbed to the MSB bit, so we can use this multiplier in any signal processing or any image processing related work. Okay, so after this method we need to go for the hybrid technique. So hybrid technique it will be come with the compressors based method. Okay, so this is a compressor based method. Okay, so here they are introduced the compressors, and that compressors they are introduced with the recursive method. Okay, so here they are split it, right, LSB and MSB. So this LSB and MSB they are introduced this compressor method. Okay, as per that it will be reduce the logic sizes, and the compressors part of the designs they are used for two compressor design, compressor 1 and compressor 2. As per that it will be reduce the logic sizes. Okay, but they are used the compressors with more logic sizes only, not for less logic sizes. So we introduced proposed new one architecture here. Okay, so we use this reference paper. Okay, so this paper is having a lot of compressors. Okay, so we take a reference from this H. Okay, so they are used for 2 XNOR and 1 NAND gate, and X4 they are given directly. Okay, so as per that the proposed compressor we are modified it, we are not use the same compressors, we are modified it. Okay, and after that we created novelty architectures in the compressor design. Okay, and that compressors we have integrated with this multipliers. Okay, totally how many designs we have done means this ones. Okay, so exact method and recursive method normal 8x8 using 8x4. Okay, and hybrid method PBO 5, and recursive method we introduce the compressors. Okay, so compressor 1 and compressor 2 and the proposed compressors. Okay, so these all the things we have compared in this paper. After that they are implemented the image processing work. Okay, so they have done Sobol edge detections the paper, but we are not yet developed the Sobol edge detections. So as per the requirement of the additional proposed we can develop the Sobol edge detections. Okay, so it is a possible work only. Okay, so this works we have developed in Verilog HTLs. Okay, so this is the exact method code, and this is a recursive method, and this one is a recursive PBO method. Okay, and this is a compressor 1 and compressor 2 proposed compressor method. Okay, so this is all the code we have developed it, and this is all the results, simulation results. So exact simulation, and this is a recursive simulation and recursive PBO. So here you can identify it, the error difference it will be came in the PBO. Okay, why? Because they are used for the OR gate. Okay, so here you can analyze it, the error came, right, so error signal. So at the time we analyze the error difference. Okay, so error difference in the PBO architectures. Okay, so here the error means it will be come with a very less error only, they are because they are ORed all the operations, right. Okay, the only carry is the issue. Okay, using OR gate. So this approximation level it will be very good. Okay, for all the applications. Okay, and after that we introduce the proposed architectures. Okay, so this proposed architecture mainly focused for the logic sizes reductions. Okay, so we will show that in a logic size reductions. Okay, so it's also came error, but error difference little differ. Okay, so sometimes high and sometimes are low, and sometimes we will get accurate values also here. Okay, so sometimes we will get accurate values also. Okay, as per the logic says restrictions, it will be good for the novelty work in the signal processing or image processing. Okay, so this proposed compressive method also integrated with the recursive based multiplications. Okay, and this work we have synthesized in a Xilinx Vertex 5 FPGA. So this is a result. Okay, exact and recursive and PBO and recursive compressors. Okay, so here you can verify it compared to the exact LUTs. It will be take 217, but our proposed compressors it will be take only 78. Okay, so here you can analyze the RTL schematic for that. Okay, so partial product with the multiplication. This is a proposed compressor architecture. Okay, and here we analyze this works in comparisons table. Okay, so here you can verify that exact 8x8 recursive and hybrid PBO and recursive 8x4 with a compressor 1 and compressor 2 and proposed compressors. Okay, so you can analyze the logic sizes of LUTs. Okay, so LUT will be compressed totally. Okay, so it will be occupied only 78. Okay, and 33 in occupied slices and 32 is IOB, it's normal one, and delay and power it will be maintaining same only. Why? Because it's almost it depends upon the logic utilizations. Okay, so how much available and how much utilizations, so it will be occupied only 1%. Okay, so here you can analyze that LUT it will be take only 1% of utilizations, and in the proposed architectures of the compressor method it's also taken 1% of utilizations. Okay, so it will be take very less only, so that's why it will be maintaining the same value approximately. Okay, why? Because this 3 common in the delay and power always common. Okay, so if we apply this multiplications in any other clock based circuits, we route with the timing constraints, means we can reduce the delay and power as per this LUTs. Okay, and we have created a abstract document in this project. Okay, so title, best paper abstract, development of this project, proposed title, proposed abstract, existing system, and exact multiplier, disadvantages, advantages, and related notes for this work. Okay, and finally come up with the literature survey. Okay, and references. Okay, thank you.